guys, a very happy morning to every one of you. And guys, we are going to see today the manufacturing technology, one of the most important subject, and as well as in the gate. And in manufacturing there are a lot of quite interesting subjects, but in that especially we are just going to see casting. So casting is one of the most important thing that you just wanted to see. Okay. So without wasting time, let us get started, because definitely they might ask at least two questions in it, or one question will be mostly 2 to 4 marks they will be asked. Okay. So okay, let's get started. So you can see the sand casting. Generally, each and every element, it means each and every phones or tumblers, and each and every, it means elements you are using. Elements means each and every material that is made up of metals is been comes by the casting. Okay, so you can see casting uses ordinary sand as primary mold material. So it's just a normal thing, because I think so by seeing a video you can understand. So I think so you can see it. So like this only the general sand casting will be. For example, you just take like this, the thing will be entirely set up, and we will just pour the molten material over it, and it will just molten material will flow. You can see the dipping. So the molten material will flow inside, and you can see. So we got the required shape. Okay. So I think so you're getting the point. So like this only most of the you can see like this. So we generally place like this each and everything, and each and everything is been taken, and we just pour that thing, and you can see how much perfectly we have just got the sand casting material. Okay, that's it. Okay, so this is a basic explanation. So it means the small grains are mixed with lot of materials and clays, and especially it means to improve the moldability and also the cohesive strength, because we do add, it means instead of using only sand, we used to add a lot of other materials also, so to improve moldability and also the cohesive strength. And they are packed, and we are just getting into liquid shape. Okay, so there are lot of type of casting. So now we are just going to see only the basic of thing, and later on as the video proceeds I will just explain each and everything. So why the cohesive and adhesive is means cohesive means attraction of the same molecule, because if sand and sand is attracted and kept in a good way, means it is a good thing. Suppose if adhesion means, you can see the sand should not have any kind of attraction with the material, it means with the mold material. Suppose if they had a good adhesion means, so lot of, it means friction, lot of impurities will start to occur. So then the pattern must be removed before pouring. I think so you would have seen about this video. So you can see, so now you can see the so now you can see this is the pattern. This small toy is that's the pattern. So he just places the pattern, and he just removes the pattern outside. Okay, now you can see he just places the this over and he just removes it. So that's the pattern. So okay, and the opening, it means opening called the spore hole, which is poured from the top of the mold. Okay, I think so in this you can see by this. So in the top hole is just pouring, so that is called as opening is called as spore hole. The molten material is posed in a spore hole and forced through the runner. It means runner under the mold cavity. So after it reaches go through the mold cavity, and then finally get here. Okay, so just a basic thing you can see. So gravity, each and everything in the casting, gravity is the main thing. So after solidification, the mold is broken and final casting is removed. That's it. So each and everything I think so you don't know. And the pattern board is placed in between the, it means bottom and the track. So you can see here we have two patterns. You can see this one is bottom, this one is top one. So what is the thing? Bottom is called as track, this bottom portion is called as track, and the top portion is called as flask. Okay, so sometimes they may have a in between, it means third pattern in between also may be placed. So sand is packed, you can see in this thing, you can see here each and everything like here is there. So that the sand is being packed. Okay, so the sand is being packed into half, and the bottom is placed on the pack. Okay, that's it. Okay, so the cope of the is kept is mold is then packed with the sand. So the mold is open. Okay, this one. Okay, so I just explained to you like this only the most of the thing you can. So you can see here, it means this is the draft. You can see this is draft, means this is the material that we just want to get. Okay, you can see here. So you can see the pouring is in here only, the material will just flow, and here you can see the gating system, and here it will come, and here the mold cavity gets a little filled up. So you can see here riser also will be. So I'll just explain. So gating system is generally will be runner, this sprue, it means the runner, this running cup, this pouring cup, as well as this sprue, as well as this runner. Okay, this riser. I think you are getting the point. Okay, so here the fire clay is also used. Fire clay is obtained at the top surface of the coal mine. For example, fire clay, I'll just type fire. So okay, you can see like this powder they will just get. So mostly it is generally applied in a coal mine. Sometimes we do take, you can see the fire clay like this, only the fire clay will be. So generally we will just take this fire clay and we will just add with the sand that's been present here. Okay, so next one is the casting drum. So casting drum, a flask, a molding flask is one holds the sand mold to impact, and it is made up of wood. It's just a normal thing because I think so you're getting the point. So just the flask is, you can see this entire outer portion. So outer portion is called the flask that holds together, and it is made up of wood for temporary applications or for long term use. That's it. So drag. So you can see this one is a lower part is called as drag. So the upper part is core. Cope. This upper part is cope, and the cheek is intermediate molding part into three pieces. Because as I have just told to you, this bottom port is drag and this upper port is cope. Okay, like that. So next one pattern, I just told what kind of pattern we need. We will just place it and we just take it out there. And the parting lining means we will divide the between two floors into half either. So bottom board is a normal thing. So you can see molding sand, freshly prepared refractory material, refractory material used for making the mold cavity. It is generally made of silica, clay or moisture in appropriate portion also. Okay, so next one, parting lines and everything. The molding here is in here easily freshly prepared refractory material is used for the melted molding. This mixture of silica, clay and moisture in a prepared position. So backing sand is just a made up of sand. It means used as sand. So backing sand, wait, I'll just show you too. Backing sand, it means BSc K. Come on, don't come on, you can see. So these are the each and everything. So backing sand is also just a process and that's it. Okay, just not just a process, it's just a sand. Okay, you can see this is made up of used, it means burned sand. Sometimes the each and every sand would have been burned by you, by it means I think so you would have seen about the brick manufacturing. In that way a lot of sands will be used, it will be entirely burned. So that kind of thing is backing sand. And core, it is used for hollow, it means hollow casting. Suppose if you see about the cylinder, it means just take this tumbler. So for this tumbler you can see like this. So this is sheet metal. Okay, it's not made up of casting, but for general industry too, you can see how much portion is there. So they will just place anything here and they will just do the casting. Okay, so the core is used for hollow cavity. Okay, so mostly the freshly prepared molding sand will be used for 70 to 80%, and the backing sand will be used so much lesser. Okay, so you can see at this center portion the material is being there. Okay, so next one is pouring basin. I just told pouring basin means they will just, you can see this one, pouring basin, this entire thing. So the pouring basin is a small funnel shape at the top with the molding cavity is poured. The next to sprue. So sprue is the running area. You can see in this sprue it runs each other and it means along. So the passing through with the molding cavity, pouring basin, which is the mold cavity. Mold cavity is what it means, what kind of products we need to get, and that's kind of pouring molding cavity. So next one is runner means the passage in the passing. I can see here the entire thing is runner. Okay, this entire thing is runner because it comes here and it goes here and it just fills the entire cavity. Okay, the gate, it means I think so how you will enter your school or college, by opening the gate. Same way, even though the pouring basin comes here, even though it means the material comes down here, there should be a gate. Based upon this gate only, it means the material will flow into the molded cavity. Okay, so you can see in the casting process a vertical channel through which molten metal flows downwards. Okay, from pouring cup to the runner. So what is called sprue. So direct answer 1 mark. So what is easy question, you can see. So next one is chaplets. Chaplets are used to support core inside the mold cavity. For example, wait, I'll just so you can see here these are the things that are used in, it means mold cavity. So these are the things, it's called as chaplets. Okay, wait, I'll just make in a perfect view. Okay, I think so you can see here. So what generally we are doing is, you can see, you can see, so we need this entire mold. For example, you can see This is running let us line like this. So this one is entirely placed like this. Okay, this is entirely sand. So suppose if we did not use any kind of supporting material means this will definitely bend like this. Okay, if we bend means we couldn't get a required dimension. So what will they do? They will just place the supporting material. Okay, supports like chaplets. These are called as chaplets. Okay, so this chaplet is made up of same material. It means, for example, if we pour aluminum here means, this chaplet is also made up of same aluminum material. Because suppose, for example, this has a what? Okay, wait. Um, Aluminum melting point is so much. 660 aluminum melting point 660 degree 60 degrees Celsius. For example, I'm just pouring in a 700 degrees Celsius because heat transfer choker. So 700 degrees Celsius I'm just pouring. So this aluminum will also start to melt and it also merges with each and other thing. Okay, I think so you're getting the point. These are the things. These are called chaplets. Okay, so chaplets are used to support the core inside the mold cavity. Next one is chill. Chill are metallic objects which are placed in the mold to increase cooling rate. Okay, for example, the same thing, guys. I'll just try once again. For example, this is the thing. So this is each and everything. So I think so you would have learned about lot of the cooling process, not about cooling process, but about the because depending on the temperature decrease and depending on the temperature increase also, the structure of the each and every element changes because FCC, BCC, face center cubic, body center cubic, hexagonal packed cubic, and the structure and the strength also changes. So it means if we need a so much rapid amount of cooling means we will use chills. So chills we will just place like this. It means it is also made up of same material. So basically chaplets and the chills are same thing. So you can see chills are used to increase. Chills are used to increase rate of cooling. That's it. So next one, reservoir. Reservoir is it means riser. Here is just a reservoir the molten metal poured in the casting so that hot metal can flow back into the mold cavity with reduction. For example, I just show you the. So you can see here they are just manufacturing the casting. So the sand has been packed and it is been placed, and you can see it's been placed, and it means the facing sand, that is. So again the cope is okay, the drag is placed, and next one the flask. So he just pushes the material down. So you can see this means the pouring cup. Now pouring cup is just placed. So you can he just took that, and you can see each and everything he's just taking outside. So now you can see now we just got the required dimension. Okay, paka. So this is the basic thing. So like that only each and everything like that. So riser is just a reservoir of material. Okay, that's it. So next one is then go for the padding. So padding is it means tapping of thinner section towards a thicker section. Okay, it's known as padding. So padding is it means, for example, you can see while you can see this is a minimum cross section. So the minimum cross section area may break at the any time. So the padding must be, it means must be placed here. If in case if we not place any kind of padding, definitely the section will be huge. So you can see if padding is not provided, the center line shrinkage or porosity will occur. So result in a thinner section. Okay, so we need the center because in during the padding like this it will be. It means here the minimum cross section, here the cross section increases. Okay, so tapping of thinner section, thinner section towards thicker section. Okay, tapping means you can see this is increasing area. So this is the thing, tapping of thinner section towards the thicker section is known as padding. Okay, I think so I can answer. So if it's been not provided means this center line will just become shrinkage. So why I'm just telling is, for example, I'm just placing here, and here it's been placed here, and you can see while just I'm just pouring, it means you can see here material is high, so rate of cooling will be low. Okay, rate of cooling will be low, but here the material is very low, rate of cooling will be so high. So you can see here the metal cools so much faster, but here you can see metal cools so much lesser. So here it gets solidified. Here it will be in a liquid state. So the contact between this will be, it means won't be 100%, it will be at least 40 to 50% only. So while you just tap like this, while you just providing a padding like this, so now uniform solidification will occur. So 100% we will just get the effective thing. Okay, I think so you can understand. So I see, you can just go to see the question. The main purpose of chapter is for which one we are just to support the code. Okay, so next one, which of the following is for riser? For riser, what we are using? So the following is used for obtaining directional solidification for riser. Mostly okay. Which one of the following method is used for obtaining directional solidification? So why this kind of directional solidification is happening? So for which one? Means sustainable placement of chills and as well as the implying padding. Okay, that's it. So B option is right one. So next one, you can see in this one, which one of the following is a gate is provided to the mold to which one to avoid feed the casting at a constant rate. Okay, so next thing you can see in this question, metallic chills are used to control cooling of this one. So P is okay, this one will just make metallic chapters support the core. Okay, Q is 1, riser reservoir middle. Okay, exothermic padding. Okay, you can see controls cooling of critical section. Okay, definitely this one. So padding is controls cooling rate of critical section. Okay, the next one chills is progressive solidification. Okay, that's it. So in green sand molding, uniform ramming leads to greater stability. Because I think so now I just explained you. So ramming is just it means just a beating. You can see here he just place like this and he just pushes. You can see, wait, he just faces facing landing, and you can see why he is now beating. You can see now why he is now beating, because of uniform solidification, because this increases the greater dimensional stability. Okay, suppose if we not beat means the sand will be not in a tighter way, so it will be in a looser thing. So this leads to the problem. So next one, green sand means definitely it consists of moisture. That's it. So now we are just going to see the pattern. So why the pattern is important in the casting? Pattern, pattern and casting. So you can see like this kind of thing, it means you can see guys, pattern is just a normal thing because it's a reference material. That's it. You can see this one here, the pattern is being placed, and after that we'll just pour the sand over it. So pattern is just a reference material. So okay, I think so you can understand. So pattern is a replica of an object which is made used when casting vessel with some modification. So it means even though the pattern also has certain modification. For example, if you want to had a beautiful girlfriend, means what you will think, she should be like this, she should be like that. Like that we used to, it means imagine. So like that the pattern also should have certain allowance. It means allowance. So it means the addition of pattern allowance, the provision of the code means elimination of fine details, which can be obtained by the casting. Hence there is it means okay. It means sometimes we need to eliminate a little bit of portion. So for that we need to have the extra allowance. So there are 5 types of pattern allowance. One is shrinkage or contraction allowance. Next one is draft or taper allowance. Third one is machining or finishing allowance. Fourth one is distortion or camper allowance. Fifth one is wrapping allowance. So okay. So what is the fifth one? Fifth one is the wrapping allowance. What is the fourth one? It means distortion or camper allowance. The third one, machining allowance. For second one, draft or taper allowance. First one, shrinkage or contraction allowance. Okay. What is the shrinkage allowance? So I think so guys, whenever you just suppose take a material and you just take a material and you heat it, and after a certain amount of time the material needs to shrink. For example, for example, I'm just telling, suppose I think so you would have drink a lot of water, so you just take the water, 1 liter of water bottle, and just place the water inside the it means refrigerator, and after a certain amount of time you can see the water would have get expanded because the temperature decreases. But here the same thing, the temperature decreases, but the volume start to decrease in here for the materials, for the metals. But in case of water, as the temperature decreases, the volume start to increase. Okay. Shrinkage allowance, all material shrinks when cooling except bismuth. Okay, so this one, okay, all material shrinks when cooling. This is because of interatomic vibration which is amplified by the increase of temperature. Because okay, so while we are just it means while we are just heating, the atoms just start to vibrate so much. They should start to vibrate like so much. So the pushing and pulling will occur a lot of there at the time. So while we are just cooling, it remains on normal state, so that the volume gets shrinked. The shrinkage allowance is always to be added to the linear dimension, even in the case of internal dimension. So we are just adding to the linear dimension in case of also internal dimension. So for example, because I gave an order, I need a material of, it means 100 100 100. So I need a material of 100 into 100 into 100. So what you are doing is, you are just making the pattern. It means you are just making the pattern and you just placing it. So for example, I just showed to you before, so that round like this, so you just placed. So because if I just pose the, it means what is the entire cube, so v cube, so v cube equal to 1 2 3 4 5 6, so equal to 10 power 6. Suppose if I just pour the 10 power 6 material inside, so definitely after a certain amount of time, what will happen, this entire thing will get reduced to 98 98 98. So the shrinkage has been occurred. So what I'm just doing it, I need 100, so I'll just manufacture as, it means the pattern I'll just redo here 102 102 102. Okay, that's it. Just a basic, just a simple thing. We will just increase the dimension, that's it. So this is comes under kind of shrinkage allowance. Okay, so you can see one thing, you can see in the shrinkage also there are quite different things. So okay, so what is just so you can see shrinkage allowance. In this shrinkage allowance, there are two type of shrinkage allowance. So one is liquid shrinkage, next one is solidification shrinkage, and there is a third thing called solid shrinkage. Okay, so liquid shrinkage means, it means reduction in volume. Whenever you just pour the volume, refers to reduction in the volume when the metal changes from, it means metal changes from pouring temperature to solidus temperature in a liquid state. For example, you just take a water, and this is the water. So it means 10 degrees Celsius, 50 degrees Celsius, 100 degrees Celsius. So you can see this one will be remain as water, but after it reaches 100 degrees Celsius, like this the temperature increases, and you can see here the steam transformation occurs. Here the entire thing is water, here the water plus of steam transformation occurs. So after this, you can see this is 100, so this is 100.001. So here the entire thing will be steam. So you can see this is the transformation. It means entire water has been converted to steam. Okay, so that's the thing is called as, here it has been notified as solidification linkage. So solidification, you can see this portion is liquid, this portion is gas. The same way this portion is for casting, we will just name liquid, solidification, shrinkage, and solid. Okay, that's it. So liquid shrinkage refers to reduction in the volume when the metal changes temperature from pouring to solid, it means to the solidus temperature in a liquid state. To account this, it means for the liquid shrinkage we are just using the riser, because riser is just a reservoir. So the action solidification shrinkage refers to reduction in the volume when the material changes from liquid to the solid state. You can see here the graph will be like this. So here the entire thing will be liquid, here the entire thing will be solid. So this especially this is called as solidification shrinkage. So you can see here the liquid and here solid. So here the entire liquid to solid transformation occurs. So it refers to reduction in the volume when the metal changes from liquid to solid state at solidus temperature. To account this, riser also provided. So for liquid as well as the solidification shrinkage, both riser is used. Okay, so next thing, the solid shrinkage. In case of solid shrinkage, you can see solid shrinkage is reduction in the volume caused when the metal loses temperature. You can see from here to here the temperature will be reduced. So this is called as solidification shrinkage. So for this, what we are just doing, pattern is include. I think so you gotta see this one 102. You will just provide extra pattern, that's it. So gray cast iron with a carbon equality, it means gray cast iron carbon equality, it means 4.3% has negative shrinkage and actually expands because of rapid precipitation. For example, maybe I'll just y Grey cast iron expense on cooling. You can see, let us ask the AI. You can see the grey cast iron expense. So you can see grey cast iron expands on cooling because of the carbon within its precipitated auto slur and low density and graphite flask. Unlike most of the material, they contract. The formation of this graphite flask occupies a greater volume because while cooling the graphite flask it just tends to expand. So that's why the entire grey cast iron tries to expand. So this resulting volume increases from overall graphite formation causes the overall expansion, making the grey cast iron ideal for creating complex casting without excessive shrinkage. For example, now for this pattern I need 100. So I'm just pouring grey cast iron, but later what I will just get 102 because the grey cast iron has a lot of graphite flask inside, so it's hard to expand. So what I'll just put, I'll just make the pattern into 98 like that. So now the graphite flask will expand and will occupy the certain, it means entire portion. So the grey cast iron only has negative, it means it expands. Okay, that's why we generally place in negative, but remaining all kind of other it means other kind of material all just starts to expand. Okay, I think so you can understand. So next one, it means I just told about the pattern allowance. This one is just a normal thing. It means for meter we just provide an extra, that's it. So 8 per 30 cm, that's it. So you can see for which one is the topmost thing for pattern allowance, which one is the most. You can see zinc is the most. Zinc, nickel, tin are the most and most of element, and the least is, you can see grey cast iron is such a least thing. Even the white cast iron also has 21, but you can see the grey cast iron has least thing. Okay, so in this you can see aluminum stinks over so much point. You can see 6.6. Aluminum stinkage is literally so much high. So next one, double shrinkage. Double shrinkage allowance is provided on the pattern. Double shrinkage is used for casting the metallic pattern, not normal pattern, metallic pattern. Okay, which would ultimately be used for molding to take care of the shrinkage of an actual metal. This one I'll just explain. Okay, no need to consider. So which one of the following metal we look at large size of casting for aluminum? Okay, because you can see one aluminum is a literally larger thing. Aluminum, copper, and which one is so much least? Least is grey cast iron. So next, low carbon, medium carbon, white carbon. See, even white cast iron also has literally 4.0 to 5.5. So aluminum is highest. So next one in 1998, which one of the following pattern requires largest shrinkage allowance while making a pattern of casting? While making pattern of casting, which one is the largest we needed? Aluminum, okay, 13. Next one zinc, white cast iron 21. So zinc, okay, carbon steel. You can see carbon steel 16 to 21. So you can see for carbon steel, for plain carbon steel 16 to 21 is mm per meter is enough. So this one plain carbon steel is so much high. So which one of the following metal strings from molten state to the solid state? Which one of the following metal strings from molten state to the solid state? Wow. Next is B. It means cast steel. Okay. Almighty metal. What is this weight? I'll just also make it out. Maybe mercury. Mercury. I think so. But alminerality. Identity. I'm just confused. Almighty metal is a almighty brass and consists 70% copper, 29% zinc, and 1% tin. Okay, and particularly thanks to the de-zinkification and composition. Okay, bad is being resistant to corrosion of seawater. Possess high thermal heat exchangers, condenser, and marine application. Excellent jobs used to export. Almighty metal is used for, it means heat exchanger, it means convection, conduction like that, and marine application and industrial cooling. For especially it is used for cooling purpose. You can see copper, zinc, and as well as 1% of tin. So in solidification of a metal during casting, compensation for the solid it means provided by the of the oversight pattern. That's it. So shrinkage aluminum is made upon. So shrinkage is shrinkage. You can see here directly shrinkage allowance is given. So For liquid, it means for liquid and for solidification shrinkage, what we'll just do, we'll, because of riser we will just get the record thing. But for solidification, but for solid shrinkage, what is here, the pattern will just place in extra. Okay, so adding external and internal elevation, adding external, so definitely A might be the answer. You can see shrinkage allowance is made by adding external and as well as the internal dimension. So for example, for the, it means we need a cylinder like this, means we'll just increase the external allowance for increase pattern, and also the internal allowance we'll just increase like this. Okay, that's it. So next one is in 2021 assignment, the shrinkage allowance on pattern is provided by the compensation for liquid when metal changes from the liquid, no metal changes from solid phase for the, so C might be the answer. You can see the temperature of the solid phase drops from freezing to room temperature. Freezing means it's the beginning of the liquid, so it's the end stage of the liquid. So the temperature of liquid metal drops from pouring, no. From the solid state, it means from liquid to solid state, no. Metal drops from the pouring, no. So C1 is the right one. So you can see about 2004. So grey cast iron block is 200 into 200 into, so shrinkage allowance for the pattern is okay. So ratio of volume of pattern with the volume of casting. Just a basic normal question. So you can see what is the, they are asking what is the volume of pattern. So volume of pattern divided by volume of casting. So you can see 200 into 100. So 1% means for 200, what is the 1%? So 200 for 1%. For 100%, 1% is 1. For 200, 202 into 101 into 10.1 divided by 200 into 100 into 10. Okay, because this is for grey cast iron. Grey cast iron. Okay, now we just cancel each other, and finally we will just get the answer. So the next thing you can see about this one, the grey cast iron blocks is 10. Okay, with a central spherical cavity of diameter 4 mm or casted, the shrinkage allowance for the pattern of the ratio volume of pattern. Wow, this is also a good thing, but you can see with the central spherical cavity of diameter which is given. Okay. So you can just go, you can see here 100 means each and everything 3%. So volume of pattern 103 into, for 50 what will be 51.5 into 10.3 divided by 100 into 50 into 10. So what is the answer? 1.093 will get. So direct answer, because they have just asked only the volume of pattern and the volume of casting, that's it. We can just go to the next one. You can see when cooling, it means a cubical casting of 40 mm undergoes 3%, 4%, 5% shrinkage during liquid and the volume compensated by the rest. You can see this one is riser, this one is 3%, 7%, because liquid solidification shrinkage and the solid shrinkage. Liquid and the solidification shrinkage goes for the riser. So 3 plus of 4% is 7% definitely. So you can see the next one, the cube casting of 50 mm sides undergoes volumetric solidification shrinkage and volumetric solidification volume solid shrinkage 4%, no riser issue. Okay, assuming you know the side of cube after solidification. Okay, what will be the answer? So let us try. Cubical casting. Okay, cube is there 50 50 50. Okay, 50 50 50, no riser is used, and side of cube after solidification. Okay, so it means what is the total volume? 50 into 50 into 50, so y equal to a cube. So it means we will get it means reduction, because here the volume is been reduced. So so definitely you can see v dash. So in this 50 will be minus of x, it means a little bit of reduced into 50 minus of x into 50 minus of x. So we can name it as 50 minus of x in the whole cube. So this one is a new, this one is a new, this one is a, both of these are new. So here 2 times the shrinkage has been occurring. Okay, it means it's been reducing. So one thing you can see here, the solidification shrinkage is 50 cube. It means since it's been shrinking, you can see 1 minus of 0.04. So we'll take this answer. So 50 the whole cube into 0.96. So next thing, it means again 50 the whole cube into 0.96, the entire thing into 1 minus of 0.06. So this one 6%. So now what's the end? Now we just need to multiply. So at last a cube will come, a cube equal to certain answer. So you take the root, definitely you will get the answer. Okay, just a simple question, no need to get confused. I think so you're getting this point. Some people might have the question like, why here 1 is been using. Suppose we can just directly go to my multiplication of 0.04. So you can see, so for example, we can also do like that, but it's just it means so you can see the 50 is a basic thing, so 0.0406. So it means for one side. Okay, but for entire cube you can just cube it, 50 into 50 into 50, so this one into 0.04 into 0.06. 300 5 into 5 into 5 into 10 power 3 into 4 into 10 power minus 2 to 600 to the power minus 2. So yeah, what is the thing, what's the value is coming? Oh sorry, I'm just I just multiply with the total thing. So instead of going to the total thing, we can just 50. So what is the total volume? 12500. So minus of this 4%. So how this 4% we can just add it? It means in this thing entirely the 4% is been reduced. So you can see in this, it means 4% is being reduced. Okay, so 50 into 50 into 50 into 0.04. So how much it will come? It will come the 5000. So while you just minus, it will come 2000. So in the 6%. Okay, the same thing, 12000 into 50 to 50, this one into 0.06. So 7500 minus of 7500. So we will get the required value. How much the value will be? 1 2 3 minus of, so 1 1. So this is the entire value. So now we just make a cube. So root of 1 1, this is 2 5, so 3 3. Guys, we are doing the right, but we are doing it a wrong way. So where where we are just making mistake. 112500. Oh, sorry guys. I'm just taking the square root. What a fool I am. So we need to take it means cube root. So you can see 48 is the answer. 27. So we can just try this one again. So 50 cube into total 0.04 into 0.06. So yeah, it means 50 into 50 equal this one into 0.04 into 0.06. So 300. So maybe this may be right or wrong, but just a guess. 50 into 50 into 50 minus of this is a thing for the wrong answer. Okay, so I think so you're getting the thing. It means you are getting the answer. So we will get the required answer. 48.5 A is the right one. It means for each and every step we have to just calculate. Don't go, it means entirely don't take a thing and directly entirely don't go. Just go in a smaller steps. So next one you can see a pattern is made up of exactly similar to part of gas dashboard. So it means pattern is used to make mold for a pattern is made exactly similar. Okay, see, exactly similar, no, little bit similar, okay, means exactly similar should not be. Similar is okay because we are also adding a little bit of extra allowance here, so the reason is correct. So next one is the draft. You can see the draft allowance to reduce the chances of damage, to reduce the chance of damage of the mold cavity at the time of pattern removal. While you are just taking the pattern outside, I'll just show you the video again. So you can see now he is removing the pattern. So you can see while he is removing the gas pattern, he is so much careful, and you can see this one. Again I'll just show. He is removing the pattern now. See how much carefully he is removing the pattern. So sometimes here a little bit of damage may occur. So that's why we are just doing the draft. You can see that to reduce the change of damage of mold cavity at the time of pattern removal, the vertical face of pattern is always tapped from the pattern. You can see like this. Suppose if we just take means there sometimes the sands may stick here. So we will just tap like this. So here the area of it means the cross section increases so much. So as the cross section increases so much, just a normal thing. So pressure equal to force by area. So as the area increases, pressure decreases. It means you can see the force also a little bit. It means lesser. I think so you can understand. So as the area, it means as the area increases, the pressure force so much decreases. So we can just take, it means we can just take the material out so much easily. Okay, because here you can see the extra force will also be in occur. So inner surface of the pattern requires higher draft than the outer surface. Okay, inner surface needed higher draft required than outer surface. So draft is, yes, definitely draft. You can see instead of having this, we need to best make it a stable. So draft need extra material. That's it. So it means here lot of friction. You can see here while doing lot of friction occurs, but here the friction will be so much lesser. And at last we will just take this, and it means we will just machine it. You can see this one, and we will just machine this side and this side. That's it. So next one is shake allowance. Shake. So you can see at the time of pattern removal, the pattern is wrapped all around the vertical faces to enlarge the cavity. You can see shake is also a simple thing. Shake. Shake allowance may come or may come. This one we will let us see. So you can see You can see there's a lot of cracks and a lot of damage has been occurring. So now we are just imposing a little bit of pattern like this. So now we can just take the, it means how much easily we can just take it outside. So this is called as draft allowance. So shake allowance is next. So we have to just shake, and you can see the pattern is getting enlarged. So you can see now, you can see the green thing is the size of cavity gets enlarged. So for example, it means the customer asked, I need a pattern of, I need a product of 100 into, sorry, 100 into 100 into 100, but I have a pattern of 98 into 98 into 98. So what we'll do, we'll just make the adjustment. Okay, it means now we'll just get the extra, it means this green size. As you can see a little bit of green here. So here, okay, green is there, so that's the thing. Okay, so this is called as something like a shake allowance. Shake. So it means while taking, we'll just put a negative. So this is the shake allowances, negative allowance. Negative allowance, it is applied to only to the dimension which is parallel to the passing line. That's it. So next one is distortion allowance. So distortion allowance, a metal which has to be solidified, it is weak. So therefore it's like to discharge. So for example, how to say means, for example, let us mention like this. So here the portion is weak. So while they are pouring, each and every metal fills here, but while you are just, it means the solidification process, the timing pressure process is going on here, most of the thing gets problematic. So here it will be a break easily. So the same thing, we'll just increase the cross section here, and later on we'll just machine it here. We will just do the machining. So that's called a metal which is just to be solidified is weak, therefore it is like to be distortion point. So the particular for the weaker sections, such as long flat portions such as U shape, V shapes, or complicated shapes which has to be thin and long section, which are connected to thicker section, So okay, I think so you can understand. So you can see in this U shape is there. You can see before. I think so, I can understand. So this is extra additional information. Wow, this is one of the good thing that I also learned here. Because while you are just replacing like this, it means you will just add extra elements like this. But when you just take it outside, this will remain. This will just change like this. You can see here it is there, here is there. So the gap is there. Okay. So instead of giving like this, what will just give? We'll just give like this. So it means now it is like this. So after we are taking it outside, it will just come to the original position like this. Okay, that's the thing. So you can see a metal which is to solidify is just a weak, therefore there is just a particular weaker section. So I think you are getting the point. That's it. So these kind of things are given for the pattern material. So what kind of extra pattern material? Wooden pattern are relatively easy to make. Wood is not a very pattern material, just a pattern is so much simple. So wood pattern is so much easy, and teak and wood wheat, it means white pine, mahogany, wooden. So metal pattern also is so much good, but metal pattern is usually so much expensive. But more distant metal pattern is usually so much stable, because sometimes while we are just using the wood pattern, what will occur? The moisture is there, and little bit problematic things also will be there, because since moisture is there, the insect will come and it will start to eat the wood. But for metal, no moisture, no insect will come, so the metallic pattern will be so much stable. And generally we use cast iron, brass, aluminum, and white metal. So white metal is antimony, tin, cadmium. Okay, we'll just write here what is white metal. So you can see white metal. So it means the specific composition values basically tin, antimony, copper, and lead and zinc also. So it means a prominent type of white metal is babayit metal, which is for low friction and wear property. So you can see this kind of white metal. So tin based white metal, and it means most of the time we used for It means low friction, high corrosion resistance, like that we generally used for bearing purposes, jewels and jewelry making and metal type also we will just use this kind of thing. Okay. So pattern metal, you can see next one. Hard plastics also we are using urethra, and often it means processed with the process that uses strong originally bonded sands that tends to stick to other pattern. So generally in full molding, I'll just say in full molding, expanded polystyrene is used. Expanded in full mold pressing, expanded polyester or expanded polystyrene is used. So next in investment casting, wax pattern is being used. In investment in wax pattern. So the general thing in the pattern material should be, because for example, ideal girlfriend should be like, ideal girlfriend means we need a girlfriend of Aishwarya Rai, Anushka Sharma, and Cleopatra, and who is the thing, Tamanna, Nayandara, Nasriya. So a lot of other things like imaginary girlfriend. Like this also one kind of imaginary thing. So easily worked, shaped and joint, light in weight, strong, hard and durable, resistant to weak and abrasion, resistant to core. It means what I'll just explain. Easily worked and shaped and joint, light in weight. Light in weight should be strong, hard and durable. Strong, hard and durable, resistant to wear and abrasion. So resistant to corrosion and to chemical reaction. So dimensionally stable and unaffected by variation in temperature as well as humidity, available at low cost. So that's it. Okay. So which one of the following patterns can be used for making pattern? Aluminium, wax, lead. That's it. Mercury we can't be used. Okay. So these are the type of extra pattern, but generally this kind of extra pattern no need, because types of pattern generally I'll just tell a single thing. So single piece pattern, just one piece. So gated pattern you will just add a little bit of extra things. Next is splitter pattern, means two pieces we will just join each other. You can see this is two piece, so one piece. So this two piece will just join together. So cope and drag pattern I just told to explain before. So match pattern means just there will be one single plate. For example, there is only one single pattern plate. Now we will just join the pattern like this. Now we will just take and these are the extra accessory thing. Now we will just take and join. So next one is loose piece pattern, means now it's a kind of, you can see just it's one loose piece pattern. So next thing you can see the loose piece pattern placed at the bottom here. So the loose piece pattern in the mold, it means avoid the mold. Okay. So this type of pattern is also used when the contour of the part is such that withdrawal the pattern from the mold is not possible. So while it means when a material is not being able to withdraw, means that kind of loose piece pattern. So next thing you can see the follow based board pattern, and the in motion IS only is asking. So the pattern which are there, small post actually we can likely to break which one is in, so follow board pattern. Okay. So the follow board pattern, you can see this type of pattern is adopted for the casting where there are some so weak, it means it's structurally weak, and if not supported properly are likely to break under the force of running. So while we are just making the force, the pattern may tend to break. So for that kind of thing, follow board pattern we are just using. Okay. Sweep pattern means just we will just sweep. It means we'll just make like this. For example, I need a round here. Okay. What I'll just do, I'll just make my pen here, and I'll just rotate. Okay. Now directly I'll just get a round. So that like that. Which used to see the complex casting by the plane by generating larger area. Okay. The axis symmetrical and prismatic in nature. That's it. So skeleton pattern means it's just a smaller thing, because here you can see a little bit of empty spaces. This is skeleton pattern. So as I just told about the cooling curve, this is the cooling curve. So you can see this is the pouring temperature 1500 degrees, and you can see here the entire thing will be superheated region. So you can see here super heat. Okay, superheat is pouring temperature, here the solidification temperature, here the freezing temperature, it means solid temperature. So here what will happen, sensible heat rejection occurs. Okay. So here each and everything, here the thermal rest and it means the entire thing, you can see total, this is total solidification time, because from a start point to end point, this is called as total solidification time. You can see from here is just it is local solidification time. That's it. We can just tell from here, because local solidification. We can also tell from the liquid and also this point of view. So you can just see this question. So this is also one of the important question. So I'll just read the question. You can see heat is removed from the mold material of mass. Heat is removed from the mold metal of mass 2 kg at a constant rate. So mass is 2 kg, so Q is 10 kilowatt. The cooling curve, okay. The latent heat of fusion, what is the Q equal to mCp delta T. So the uniform residual, so during cultivation latent heat of fusion means we will just take this thing. So here 873, 10 yes and 20 yes, so 873 latent heat of fusion. The latent heat of fusion, okay. Okay. Q equal to mass into latent heat. So okay, I think so everything open. So since Q is given as a 10 kilowatt, so we need to just make the each and everything equal. So Q is kg into latent heat is what is the thing, kg, it means kilojoule per kg. So you can see kilo, kg cancel, and here the entire thing will be Q. So what is the value of Q is 10 kilowatt. 10 into 10 power 3 watts is joule per second. So we need to cancel the second. So you can see 20 second and 10 second. So 10 second will be, so 20 minus of 10 second. So second will be second will be cancelled. And now it's been here 10 into 3 into 10 equal to mass into latent heat. So this 2. So what will be the value? See here kilojoule is been there and there kilojoule, okay. Then 50 into 10 power 3 equal to latent heat. So 50 kilojoule per kg is a latent heat. Directly we just got the answer. I think so we were getting that point. So next one, fluidity. Fluidity is just the ability of metal to flow and fill the entire mold. That's it. Okay. So I think so we're getting the one. So okay guys, we can just see in the next video. And until then, take care. Bye bye. Have a good day.